at the top of these notes, you'll see where it says essential questions. So we have 2 today. The first is, what are inverse operations? When we're done with these notes, you should be able to explain that to me. The second is how you solve an equation in general. So let's go over some definitions. Inverse operation. An inverse is just like a fancy word for opposite. So inverse operations are 2 operations that undo each other. If at any point you can't read my handwriting, please tell me. Just raise your hand and ask what you cannot read. Two operations that undo each other. Can someone raise your hand and give me an example? Kieran?
Positive 2 and negative 2.
Right, so adding 2 and subtracting 2. So plus or minus. Plus slash minus. What is another example? Jackson, thank you.
Multiplication and division.
Exactly. So in math, or in higher math, we use a dot for multiplication because we use a lot of x's, right? So when you see the dot, that's multiplication. The solution to an equation is a value that makes the equation true. Now I'm not going to write this down yet. I'm just going to write down this word, equation. Equation. What word do you see in that word? Equal. So equations have to have an equal sign. And so a solution makes it true. It makes it equal. So solution makes it equal. We'll say makes it true. So a value that makes the equation true. Let's make a super simple equation over here. Let's do x minus 2 equals 5. Class, what's x? What minus 2 is 5? 7. So x would be equal to 7. So my solution would be 7 because 7 minus 2 is 5, so make it 5 equals 5, which is equal. Reciprocal. This is a weird way to say it, but this is actually the technical definition, is a pair of numbers. I'll say a pair of fractions. We'll say it like that. That multiply to 1. So an example would be 2/3 and 3/2. It's just a flip around version of it. And so in math we call that a reciprocal. Flip it upside down, reciprocal. Other definitions here. Properties of equality. I didn't want you to write it out because these are important, and this is how we solve an equation, but I don't need you to write everything. So these are the properties that allow us to maintain balance. Addition property of equality says I can add the same number to both sides. As long as I do it to both sides, it makes an equivalent equation. So it doesn't change anything. So we are allowed to add the same number to both sides. Subtraction property of equality says I can subtract the same number to both sides, and that's allowed, right? It's still equal. Multiplication, same thing. I can multiply the same number to both sides, and my equation is still equal. And division is the same thing. I divide the same number on both sides, and it's still equal. So when we put an equation together, we do it in order of operations. We go parentheses, exponents, multiplication, division, addition, subtraction. So this is how we do. This is how we put an equation together. If I want to undo an equation and solve it, then I go backwards. So reverse order of operations. I do addition, subtraction, then multiplication, division, then exponents, then parentheses. So when we're solving an equation, all we're really doing is we are undoing. So this is how we solve. Is this ringing a bell? Okay. Sometimes you'll see me write it like this. PEMDAS. Like that. That's how we solve an equation. Whatever way works for you. Now, when we solve equations in this class, you're going to see me draw a line down the equal sign. I'm doing that for a couple reasons. First, I'm reminding myself that there are two sides, and what I do to one side, I must do to the other. I'm also keeping my work organized, because some of you guys just start adding, and it ends up on like the other side of the paper, and I do not know what's going on. So, I'm going to draw a line. So we have W plus 5. Guys, how do I undo plus 5? Yeah. Minus 5. So I'm going to draw a line. So this tells me you've just done an operation. 5 minus 5 goes to 0, right? So we get to cross it out. It's going to 0. And so 13 minus 5, guys, is 8. So I say W equals 8. Now, I'm going to make you do, so that was undo, right? We just solved an equation. We undid it. Whatever. Okay. So now we're going to do plug our answer back in and make sure we got it right. When we solve equations, you should know right away if you're getting it correct, because you can check your work. So I'm going to take 8, and I'm going to put it where the W is. So I'm going to instead of putting W, I'll put 8. 8 plus 5 equals 13, question mark. If it does, then we did it right. And I do want you to write this down. Guys, what's 8 plus 5? 13. So 13 equals 13. Is that a solution? Yes. Okay. We're not going to do this on every single one, but I'll make you do one per section. So if you did not add that, you need to go back and do it. I know some of you guys are working ahead because you've solved these equations before. Go back and check your work. 6 plus D equals 5. What operation do you see?
Plus or addition.
And how do we undo addition? Okay, now, here's why it's addition. It is not because it's plus D. I need everyone to look. Look. Those in the back. It is not addition because you see plus D. The reason it's addition is because this 6 is positive. That's why it's addition. Okay, so we're doing addition, so we undo it with subtraction. I've got plus 6, so I need a minus 6 to both sides. Please make sure you show me it happening on both sides. Subtract 6, that goes to 0. And so 5 minus 6, use your number line if you need to. I'm at 5, I go down 6. Isaiah, where am I at?
-1.
Thanks. D equals -1. Again, we can check it. Is 6 plus -1 5? Yes, we did it right. And I'll usually box my answer like this. That was weak. And so we've got subtracting 11, so how am I going to undo it, Lucas? How do I undo subtracting 11?
Adding it.
Yeah, so we're going to add 11 to both sides. Oh, man. Plus 11. Plus 11 goes to 0. So we get to cross it out. So x is equal to 31.
Wait, yeah, I tried to multiply.
Now, again, you can check your work. So that was undo. And now we can do to check our work. So order of operations. 31 minus 11 has to be equal to 20. Is it equal? Yeah. So, yes, that is our correct answer. That is the solution because it makes the equation true. 20 equals 20. This one is a good one. This is not addition, right? We are undoing subtraction because we're trying to take away this -1, and it's -1. So we're going to add 1 to both sides. Goes to 0. And P is equal to, okay, I'm at -3 and I go up 1. If I'm at -3, I'm up 1. Where do I end up, Hannah? Where do I end up? Yeah. So p equals -2. -1 plus -2 is -3. That is the correct solution. When we see a number right next to a variable like this, what operation is that? Multiplication. In class, everyone, what is the inverse of multiplication?
Division.
Great. So we're going to divide by 2. You're going to see me use the fraction bar to show division. If you like to use the division sign, go ahead. But I would encourage you to get comfortable with using the fraction bar. So this goes to 1, which is why I get to cross it out. And W is equal to 48 divided by 2. Now you could do 40 divided by 2 is 20. And 8 divided by 2 is 4. Put them together, 24. We can check our work. So that was undo. You should know right away if you're correct by plugging it back in. When I say plug in, replace the variable with the number you got. So do 2 times 24, parentheses like this just means multiplication, should be equal to 48. Is it? Yeah, so I write 48 equals 48. Put a check mark. Yes, that is the correct solution. You should know right. That just means division. So, class, what's the inverse of division? Great. So we're going to multiply by 3 on both sides. I'm going to do that by putting it in parentheses like this. 3 over 3 goes to 1. So I get to cross it out. So I'm left with x is equal to, what's 12 times 3? Yeah. It was undo. Now we're going to do to check it. Whatever I did. So 36 divided by 3 should be equal to 12. And it is. So 12 is equal to 12. Yep. That's the solution. Kevin, I've got division by 5. So how do I undo it? On both sides. Multiply by 5, multiply by 5. That goes to 1. And 15 times 5, you can use your fingers. It's not going to bother me. 15, 30, 45, 60, 75. So x equals 75. Take this, and if I multiply by the reciprocal, Justin, what's the reciprocal of 2/5?
3 or 5.
Flip it over. So what's the reciprocal?
2.
5 over 2. Yeah. Put you on the spot. We multiply by 5 over 2, which is the flip of that. Okay. This multiplies to 1, right? Because you get 10 over 10, which is 1. Which is why I get to cross it out. We'll say it goes to 1. The tricky part is dealing with what's over here. 10 is not a fraction. How do I make it into 1, guys?
1.
Thank you. And then we just multiply straight across. So 10 times 5 is 50. 1 times 2 is? So now we need to simplify this. Divide it by itself if you can. So that would be 50 divided by 2. Yeah. Or simplify the fraction, right? See what the top and the bottom can both be divided by, which in this case would be 2. So 25. That was undo. Now we will do. Check it, especially when you have fraction ones like this. So our answer, 2/5 times 25 should be equal to 10. Again, 25 is not a fraction. Let's make it one. Let's multiply straight across. We get 50 over 5. What's 50 divided by 5? 10. So yes, that is my solution. One more reciprocal one. Oh, go back. Tell your partner, what's the reciprocal of 1/3? Oh, I heard it. Beautiful. Yep, 3/1. So we multiply these two, and they go to 1. So we get to cross it out. And this would be 45/1. Is that right?
Yeah.
Check my math. So m is 45. So the rectangle has an area called A. Write and solve an equation to find the value of x. What you see here is us. Go. This is me defining my variables. So define your variable. You can't just put x in an equation and expect who's looking at it to know what that means. So define it. So if we're going to use x, x would stand for, someone raise your hand and tell me, what would x stand for? Let x be equal to what? Yep, it's going to be something in inches. What is the, so I'm going to put that. So inches. What in inches?
Squared.
What's this? The length. So what's this?
Width.
Oh, okay, so it's the width in inches. Great. So when we do area, recall the area is length times width. So we can just replace those things now. It says that the area is 54 inches squared. So we're going to change it to 54. I want you to go ahead and write an equation, even though I know you can probably do this in your head. The length we know is 12. And we said that width we're going to change to x. So yeah, divide by 12. I believe you get a decimal for your answer. So if someone's got a graphing or a scientific calculator, you can put it in there. 5 inches. The width is 4.5 inches. So I'm going to write a sentence. If my pen works. Width is 4.5 inches.